Okay, in organic chemistry, you can get really complicated molecules, and it's hard to know where to begin when you're asked to look at how that molecule reacts with another one. And there's a really easy way to go about this, and that's to look at the functional groups. Now, functional groups are groups on the long molecule, which are the parts which will react. So, for example, say you've got a really long carbon molecule, so you've got CH3, C, H, CH3, CH2, that capital, CH2, and then you've got C, and then you've got that on the end. When we're asked to say, right, okay, how would this molecule react with another molecule? What possible ways could it react? Well, the simple answer is none of this end here is likely to react with anything at all. And this part here is known as the functional group because it will react with other molecules. The first way in which it will react is it will give up the hydrogen and it will be replaced with a different group, such as an R group. So it will react with an OH, so a alcohol group, to create, then that will go away. Just erase that. That will go away, and then you'll have the rest of your OH group there. So we denote that with R, and then you'll have plus H2O, and that's if it reacts something like ROH, something like that. It will do that. So you know that the functional group will react and form. It's the only part of the molecule which will react, which makes things a lot simpler. So if we get rid of all of this, okay, there are a few different functional groups which you need to know about. The first is a hydroxyl functional group, and that is literally R. Now R denotes the rest of the molecule. It can be any amount of any length of hydrocarbon chain or benzene rings or whatever. It's just the rest of the molecule. Okay, and then OH, and that's your hydroxyl functional group because it will react. It's also an alcohol. Okay, you've got an alkene, which is basically any molecule with a double bond. So, for example, again, we can denote R's by different groups. So carbon, double bond to a carbon, and obviously we need to fill up all the valences for the carbon, so that's going to be 4 per carbon. And as you know, we're denoting the different R groups with different superscript to denote that they are different rest of molecule chains or benzene rings or whatever. We've also got amino groups, which have got NH2 groups attached to them, so they're NH2 only. So for example, we can have R, NH2, or you can have something like R1, NH, R2. Sorry, no, that's wrong. We want to put the 2 as a superscript, not a subscript. Just like that. There you go. So these are all amino groups. Okay. Now, an amine or amide group, AMIDE, is similar to a amino group in that it has NH2, but it's also got some other bits. So you've got R, so the rest of the molecule goes to carbon, a double bond to an oxygen, and then you've got the NH2. as well. Okay, and that's an amide group. Now, the other important group is a carboxylic acid group, which is like an amide group, but rather than the NH2, we have an OH group. So we've got R for the rest of the molecule, to a carbon, double bond to an oxygen, and then we've got OH down there. And normally it's the, as I showed you earlier, it's the OH in this example which will react. And the other one is a halocane, which is anything. So the rest of the molecule attached to an X. Now the X can represent any of the halogens. So that's going to be fluorine, chlorine, bromine, or iodine. And they're the halogens which can represent X. And those are the main functional groups that you're going to find in organic chemistry molecules. There is one other, which is just like the carboxylic acid group, but instead of the H, we will, in fact, I'll just do this now. We won't have the H, so we'll get rid of the H. Yeah, we'll just draw it in. So we won't have the H, but we will have another R group. So if we do an R1, that's going to be R2, and that is a ester. Okay, I hope you found this tutorial useful. Don't forget to check out my other videos, like, subscribe, and comment.